Good evening, everyone. Today, I'd like to present the paper of integration of blockchain technology in collaborative scientific workflows. My name is Xiong Lu. I'm currently a professor at Wayne State University. I work this paper with my co-author Jingwen Liu, Yong Zhao, and Chanxing Bai over here. I'd like to give my thanks to my co-authors. First of all, this is a survey paper, so I'm going to keep it brief, but trying to focus on the exciting part. Especially one of the paper is we survey is our own contribution. So we like to spend a couple of minutes more on that paper. But the rest of them we have surveyed over 50 papers. So we are going to focus on only the representative work in this presentation. Here's the outline of our talk. We are going to give a little bit background on scientific workflow and blockchain, and then bring up the discussion about opportunity and the challenge. We're going to focus on a couple of papers for the case study in this presentation. Then we are going to discuss a little bit about future direction and conclude our presentation. So first of all, scientific workflow have been used in many domains to manage and analyze scientific research data across different stakeholders. And the challenge really is, besides being a large data set, different format, and different the 3D challenge, other challenges include data integrity, provenance, collaboration, and trust. And these are the challenges we are going to focus on in this survey. And for this challenge, blockchain is really a good technology which can offer a decentralized, tamper-proof solution over here. So, scientific workflow have been very important to automate and manage scientific data analysis, which could be very challenging because of the huge data set and the exploring the unknown, as well as the exploratory nature of scientific discovery. So the key feature of scientific workflow include automation. We want to automate many of the steps of the process as soon as possible because many of them are routine. Integration of different tools, solutions, and data set, as well as collaboration, because not a single person can solve the problem nowadays. We have to combine all the expertise, data set, facilitate, and so on. But more importantly, we need to make the discovery reproducible, because if we cannot reproduce it, then the discovery, is not as useful. It's going to be like by chance. So blockchain comes up, have several great features, including it's decentralized, there's no authority in control, it's transparent, every transaction you do, every operation you do is trackable, monitorable, and it's immutable. Nobody can change the records on the blockchain. It's secure. There's also a lot of cryptography protection there, including the signed signature, Mogul proof, and so on. And interestingly, also the smart contract, which is programs on the blockchain, they can automate many of the processes that we need in scientific workflows. So the blockchain can really bring to the table about ensuring data integrity in terms of checking provenance in terms of the steps that we use to derive a data set. And it's going to foster decentralized collaboration, including people we don't even know. And so traditionally, we have to build a lot of rapport and trust between each other. So now we can more focus on the expertise and then trust. We can rely on the technology to bring to trust part over here. And it can automate process using smart contract. So the data integrity, for example, you can ensure it by Merkle tree, in which you can calculate for example, the hash for each data set, and then all the way up to the root. And then even we change data, one bit, for example, of one of the data set, the root is going to be checked. And one of the wonderful things is we don't need to store the whole data set on the blockchain, which is going to be too expensive. We can simply only store the root, which is 32 bytes. And then that 32 bytes will ensure that we cannot even change a bit of the huge data set. So this is going to improve a lot of problem checking. One of the people I'm going to talk about is we can store a huge data set offline, but only, for example, save the hash in the blockchain. So that will facilitate really the collaboration among scientists. And we are talking about trustless collaboration, means we don't really have to based on assumption that we can trust somebody. Okay, and then we can execute a workflow, or especially some of the step of workflow using smart contract, which is pretty good at checking the constraint, and pretty good when checking the event when some event happen. We are going to automate the processing. And finally, it's also help privacy preserving data sharing, because all you need to have a wallet, to have an address. You don't really have to show your name, but still people can trust you because you have a digital identity, although people might not know your real life identity, but they do know your digital identity. So that trust can be created around that digital identity of theirs. So the challenge for blockchain integration, number one, is scalability, because we are talking about a large data set over here. So how we can scale in the context of blockchain and scientific workflow. And the interoperability, how we can integrate with the existing tool, that's always a challenge. And regulatory compliance, nowadays, we need to make sure that we're not going to show the real ID of the person. We want to preserve those privacy. And then user adoption. We're always talking about not beautiful theory, not beautiful math, but we really need to create a tool that people can use to address the issues in real life. And we want the learning curve to be low so that even undergrad students, for example, without a little bit of training can use it. So here's the taxonomy of all the blockchain application in the area of scientific workflow. First one is along the line of data integrity. It's always the first one. Second one is problem tracking to promote reproducibility. Third one is collaborative research. Especially we want to build a workflow that's collaborative, not just from a single institute. And we want to automate as many steps as we can. And we want to share data with each other. Some of the data could be proprietary. So data sharing will be a challenge, how we can share the data while still maintaining the ownership or some other regulation of the data. And of course, when we share the data, we have to make sure privacy will be preserved. So let's talk about data integrity and provenance. The blockchain can really provide the feature to ensure tamper-proof records, because nobody can modify the records once they are written on the blockchain. And provenance can enhance the reproducibility, because every step of the process is recorded. For example, giving a step, we know what data input is used, what input data set is used, what output is produced, what parameter is used, who is involved. So all those details about every step of a workflow is checked and also stored on the blockchain with the immutability guarantee. So one example is if it's involved multiple institution study, so every step along the way in each institution is stored in the tamper-proof records, and no institute can fake the data, fake the step, and afterwards. So scientific fraud will be prevented. And also it's going to facilitate collaboration, because decentralized sharing, we can ensure everybody can access it. So accessibility is much better. And then also your contribution is your contribution, my contribution is my contribution. And then all those are ownership and credit can also be kept track of on the blockchain. And a smart contract can use many rules. One of the things I like smart contract is they have this so-called require statement. and you require precondition. If the condition fail, then the whole function will be cancelled. Anything you have done so far will be rolled back. In other words, every single transaction or function in smart contract is transactional, either all or nothing. So that's a beautiful concept that we learn from database area, but now it's more general. And then it's also trust is important in collaboration, but now trust is not based on just you have to go to coffee, drink coffee, be friendship, but also is ensured by the technology as well. So technology really helped the trust. So today I'm going to focus on 3 case study. We have more case study in the paper, but I would like to focus on the first one, Prism, SignBlock, and then BlockFlow, especially SignBlock is our own research. So provenance tracking for fraud, the prevention. In scientific, in science, we although we know that ethical law is taught a lot, still scientific law always happen here and there. So one of the things we concern about is, can we use off-the-shelf blockchain today to address the fraud prevention problem? And these people look at the existing blockchain. They find that existing blockchain lack fairness and reliability. So they propose a new consensus protocol to address this issue. And another issue is the difficulty in allowing workflow changes while maintaining accuracy. And this is important because it's in scientific discovery, they're not going to just use a fixed workflow. The workflow can keep changing in terms of parameter, structure. They might have new hypotheses, and that will lead to evolution of workflow. So it's a norm rather than an exception. And then there's also scalability issue that task execution and management could be very challenging. So that's the issue that addressed by Prism. So the contribution made by Prism is they use a blockchain to keep track of the provenance and make it immutable. And then they propose the so-called proof of earned reputation as the consensus protocol. So in other words, academic, you have reputation. So reputation is your most valuable value. It's not how much money you bring to the table, but how much reputation you bring to the table for collaboration. So in this consensus protocol, the reputation becomes important. So this is different from the proof of work, which is based on how much computing power you bring to a table. Also different from proof of stake, which is how much really money you bring to a table. Here, they base on reputation. So this fit the academic area better. And the workflow adaptability, they allow workflow change, and all those changes will be maintained and also stored on the blockchain, so people know what have been changed, who changed it, and why. And to address the scalability issue, they use a so-called task sharding. Basically, divide a huge task, into a smaller task, and then they can be mined by different miner for scalability. Okay. So those are the challenges addressed by the Prism. What about the SignBlock? This is one of the work we have done. So in this one, we address the issue of forged provenance or tampered. We don't want people to change it. And another thing is we do need to sometimes do invalidation. So for example, we discover some data set is error prone. We found that the experiment have some issues. So that means the data produced by the scientific experiment has some issue. We need to invalidate it, and including invalidate any downstream data set that produced by the raw data set. So how can we do that? Well, this is going to be contradictory with the immutability property on the blockchain. So what we do is, to address this issue, we have to have new solution here. The next one is query limitation. You really query the provenance on the blockchain. It's going to be not efficient because yes, blockchain can can support the query, for example, transaction number, wallet number. Those can be very, very efficient. But other more complicated query for provenance will be very difficult. For example, if you want to find out, recursive query, find all the ancestors for all the descendant. So those are not hashed by the blockchain. They are not provenance or workflow oriented. And last one is we also have the lack of trust in distributed collaborative environment. So the sign block address the issue by storing the provenance on the blockchain. And then to address the issue that we might need to invalidate some of the provenance, we introduce a new marking technology so that we know when we query, we know if a particular provenance is outdated without deleting it, because we cannot delete a provenance anymore. So what we can do, we can only append new record to invalidate older record. So that means when we query, we are going to query the new record first to make sure that any existing provenance record have not been invalidated yet, and then we present that query to the user. And then we also introduce the hybrid approach, which is combined database efficiency in query with the blockchain immutability. So in this way, blockchain will ensure integrity, but database will deliver the efficiency of query. And then, so we have created a prototype on Ethereum and look at performance. Of course, Ethereum is very secure, but however, efficiency is the problem because every 15 seconds you produce a block. So we are looking at L2, maybe roll up technology in the future and see if we can save provenance on a much scalable blockchain. And recently, we can also look at Sway, look at optimism, and so on, including Solana. So the key challenge addressed by Blockflow, including reproducibility crisis, many work are not reproducible, address the issue of provenance, as well as confidentiality and trust. So the last one I like to talk about is Blockflow. Blockflow is addressing reproducibility, provenance, reliability, confidentiality, and trust. And so they are also similar to SignBlock. They are using the provenance data. SignBlock is one of the early work, so it inspired many other research. And they introduce also access control to sensitive data collaboration. And we know the smart contract language like Solidity is pretty good in ensuring access control because they have the so-called modifier. Every function can add a modifier to ensure who and when and where, and from where they can call this particular function. And then they also enable reliable tracking of data transformation from origin to result. So these are all checked in the provenance. Finally, they provide a blockchain-based peer-to-peer system to ensure that people can trust each other over here. So future direction, we can, right now it's an AI era, so including also Internet of Things, so we might be able to build blockchain models that can be used in collaborative scientific workflow, integrating AI and Internet of Things. So for example, can we build a new workflow from existing workflow or existing execution so that we can explore the new version of the workflow in a smart way. And then the next one is the efficient provenance capture and storage. We can look at more scalable blockchains and see if we are able to store the provenance on the blockchain and then query using efficient mechanism. And then decentralized collaboration platform. So with the blockchain provide the trust, So we can expand collaboration more easily, including forming ad hoc collaboration for a particular purpose. People can join, and we can even use incentives such as tokens to encourage collaboration and so on. And more importantly, is we need to have a user-friendly, user-focused design, UX design for wide adoption. So that's a future direction. So in summary, the benefits of a blockchain integration, not excluding others, is transparent, number one, and the reproducible research. This is probably the number one importance for scientific discovery. We want to be able to trust what we found. And then we are able to automate to improve productivity. It's a survey that AI already improved many of the top scientists by 80% of productivity. So workflow can automate many of the tedious work that done traditionally by either by hand or by writing a script, but all those are scattered and ad hoc solutions. So can we streamline and automate it? And finally, in order to address many of the grand challenges today, we have to collaborate. We have to work together. For example, physics, biology, and medicine, they all have to collaborate in order to produce something meaningful and impactful. All right. So to conclude, blockchain address many of the key challenges in scientific workflows, and then we solve more problems, and then more challenges will come. And then it's offer solutions for integrity, collaboration, as well as automation using smart contract. So one of the things we feel excited is we want to look at how smart contract can automate collaboration, as well as automation over here. So, and that's what we're going to look at. So thank you so much. Any questions?